Good morning, everyone, and welcome to this World Resource Forum webinar on circular economy with a focus on plastics. I'm very happy to be here. My name is Katharina Benning. I'm from ETH Zurich, and I very much welcome the presenters of today, which is Tahira Goga from the Council for Scientific and Industrial Research in South Africa, Carlo Ciotti from Vinyl Plus in Italy. We're still waiting for Deep Wonder from Australia, and then it's Henning Wilz from the Wuppertal Institute in Germany. The procedure is as follows. Everyone has about 8 minutes to present, and then we have a couple of minutes for clarifying questions, and then we'll have a Q&A in the end. And I would very much invite you to write your questions in the Q&A chat, and then we will take them from there. Okay, thank you very much for being here today. And with that, I hand over to Carlo. Please, Carlo, we are looking forward to your presentation.
Okay, you showed my presentation, sorry? Hello?
I think either you can share your slides or, sorry, now we have Tahira. Tahira, would it also be fine for you to start? I think we have it in that order. I didn't know.
Yeah. Morning, everyone. Thanks to the chair for the introduction. I'm just going to quickly take care of the technicalities and share my presentation. There we go. So good morning, everyone, once again. Tahira Goga, researcher at the Council for Scientific and Industrial Research, more commonly known as the CSIR, and we're based in South Africa. I'm here to present some of the findings of our ongoing study, and I've titled it Environmental and Social Exploration of the South African Plastic Sector. So what is happening currently and what is the status of the South African plastic sector? There's obviously quite a lot happening, but at the moment, just the three main points. Number one, that it's fairly well developed. The sector itself, just under 3% of the country's GDP, and just over 21% of the economic output. The recycling rate, that is the mechanical recycling rate, stands at over 40%. So it is quite well developed in that sense as well. However, sort of a counterpoint to that is the fact that the waste disposal, the formal waste management system is for about 2/3 of the population. And therefore, there's about 29% that actually don't have any formal waste management system. There's also inefficient sorting and collection facilities. And then in terms of the recyclate, where exactly does it go to in terms of the end markets? And the end result of this is that it leads to some sort of a considerable amount of material that is either cannot be recycled or is unable to be recycled. So in terms of some of the legislation and regulatory policies, we have the extended producer responsibility. This was promulgated and amended in 2021. We have, I think, notices for about 9 categories. So the one that I focused on, obviously, for the contents of this presentation is the paper, is the plastic and packaging and products. However, there are a couple for lighting, pesticides, electronics, etc. And what it does is, amongst one of the objectives, is it sets out targets, reuse, collection, and recycling targets in particular for PROs to actually achieve. And then you have the Plastics Master Plan. There's also some targets that are there referring to, there's a social component there, but there's also some targets in terms of recycling rate and then the trade deficit as well. So that speaks to the economics. South African Plastics Pact, this is the voluntary pact that aims to transform the country's packaging sector in particular by 2025 by setting out a couple of targets as well. And then we moved on more to the decarbonization aspect. So in terms of the two that I've highlighted, it's Sasol, which basically produces the synthetic fuels, and plastics in South Africa is produced from this coal to liquid process. They've actually set up a 30% target by 2030 for their scope 1 and 2 emissions, which actually does impact the plastic sector. And then lastly, the integrated resource plan for electricity, and this also sets up some sort of modeling for where we see our electricity and what's happening in the national grid in the future. So in terms of the particular framework that we used for our study, we started off with some sort of reference case, and the best data at that stage was for 2018. We incorporated South African factors such as the monomer production. So I've mentioned this, that the plastics is produced by some coal to liquid process, and there's some sort of gasification in there. The electricity mix in South Africa is predominantly, for the most part, it's you have your coal-fired power mix, so about 80 to 90% it's dominated by that. And then lastly, mentioned this in my first slide, the fact that you do have this informal disposal, and this accounts for your unsanitary landfill, your dumping, and your burning. So from the 2018 base case, then we basically sort of projected to what's happening in the short to medium term, that is 2025 to 2035. And then we looked at a couple of mitigation or alternative scenarios, and these are both circular and decarbonization in nature. On the circularity aspect, we looked at increased recycling. So for example, in 2035, if we reach our 70% recycling target, what impact does that have? Your demand moderation. So this is in terms of you shifting your single-use consumption to reuse, and then decarbonization. So if you reduce that percentage or distribution of coal-fired power, what impact does that have in terms of greenhouse gas emissions? And we did this through a combination of industrial ecology tools. I think they're quite familiar to the majority of you. That would be material flow analysis. That gives you a couple of mass-based and circularity indicators, and then you have your life cycle assessment. I think the one that is most popular is your global warming potential. However, there's generally a suite of about 17 to 18 indicators. And then we've added in the socioeconomic indicator that speaks to employment. And how is this shown? I won't be able to show it in this particular presentation because of time constraints, but we did show it in terms of a Sankey diagram, some sort of dashboard, and also via graphical format. So in terms of results, I've just shown 2 result slides for today. There's quite a few more. So this was the Sankey diagram that was produced for the South African plastic sector in 2018. Sankey diagram just means that the width of the arrow is proportional to the quantity of flow that flows through any particular sort of stream. I think a couple of things maybe about the slide, the fact that we did show some sort of accumulation within the short-lived or within the durable use. So that does show that there is some stock and that not everything, being produced and used actually comes out as disposable within the same year. The second thing is that this diagram does show circularity in the form of your recycling. So in terms of massive flows or big flows that pop out, you can see that 954 that comes out from conversion, that's basically just over 50% of whatever is converted in South Africa into products actually comes out as waste within a single year. So that is basically your single use to short-lived use or consumption. The second thing to note is that the 3 streams that come out from your disposal, you can see that some of the deficient landfill and the self-help disposal actually make up about 2/3 of what is being disposed. So what does this mean? Exactly what I said right at the beginning. So you have about that 1/3 of the population that is not this actually shows more than that. 2/3 of what is being disposed, rather, so that is excluding what's being recycled, is actually not being formally managed. So it's not going into any sort of compliant or sanitary landfill. And then on the bright side, just wanted to mention that the recycling, the 473 that comes out is, I think, equivalent to about 40.3% of your input recycling rate. In terms of the results, I just wanted to mention it's important when we speak about indicators, matrices, findings, that we do attach definitions to these, because people talk about recycling rates, people talk about recyclate, talk about pollution, but we need to equate those to some sort of, first of all, definitions and then numbers. Otherwise, really difficult to compare. And then we went a step further. I've mentioned this already, I think, in the previous slide. So I've had to leave out one of the results slide, but I've jumped to sort of where is the trajectory from 2018 to 2035, and in terms of the mitigation strategy. So what you can see is, okay, reference case and baseline, dotted black line, and then you can see the alternative scenarios. On the recycled content, the demand moderation is sort of it's behind the reference case, so that's why it's not shown. However, you can see that increased recycling does put up the recycled content, similarly to leakage. However, I think what is more important is that if you look at where the combinations, that is obviously the combination of the scenarios, what impact does that have? First of all, it's actually in the case of recycled content, it's about 2 to 3 times higher than what it was in 2018 if we combine scenarios. And in the case of leakage, you can see that it's substantially lower than what happens in 2018. So I think this is important because it shows that despite increased production, despite increased consumption, if we combine these scenarios, you actually not just end up with indicators and impacts that are better than 2018, but there's actually that percentage reduction. And that's what's highlighted in the overall the numbers. So 41% increase in recycled content, 25% reduction in leakage. And then if we look at the case of global warming potential, where that decarbonization strategy comes into play, you can see that there's actually a 38% reduction. And this is the reduction based on what is happening or historically in 2018 compared to what is being projected in 2035. Then in terms of the social exploration, and I'm on to like my second last slide, so I should be done fairly quickly.
Okay, great.
No problem. What we've done so far is more quantitative. So we just looked at the breakdown of employment per life cycle stage. What we want to do now is actually extend that a bit further. So first of all, looking at the paradigm of the just transition, and then secondly, looking at documentation such as the informal reclaimer and waste picker guideline. We actually want to qualify, so in terms of the quality of those jobs, and then secondly, attach that to some sort of skilling aspect. So do we expect that there would be some sort of reskilling or upskilling required in the future? I think I've kind of mentioned the conclusion. So basically, the fact that, each individual strategy displays some sort of benefit. However, it is the combination that is expected to deliver that immediate improvement and a 25 to 41% reduction by 2035. These do align with other studies. And then in terms of the way forward, I've just listed the different objectives that we'd want to achieve for the social assessment. The slides would be available. So just to mention that this has been published, and we've been honored that our last publication was actually awarded the Outstanding Article Award by the South African Journal of Science in 2023. And just an acknowledgement to the funders. Thank you, Chair. Thank you for everyone's attention.
Thank you very much, Tahira. Are there any immediate questions? We would have 1 minute left for any clarifying questions. I see that there are no questions in the chat. Okay, then we'll discuss, I think, more broadly later on in the overall discussion. And then I would like to ask Carlo, sorry, Tahira and Carlo, that I mixed up your presentation in the beginning. So, but now it would be Carlo's turn. Thank you very much. Carlo, you are still muted.
You can call me?
Yes, yes,
Okay,
great.
perfect. Okay, my name is Carlo Ciotti. I am working on, I am present as plastic of the PVC, polyvinyl chloride. That is one of the biggest polymer that used in the plastic field. You can change the next slide. I am not able to. Okay, thank you. Next to the name. I am presenting the project WRF. That is the name is Waste Recycling Project that was started 5-6 years ago in Italy with the target to separate in the bulky waste present in the urban waste, the PVC from the other plastic to go to the mechanical recycling, to use the PVC or mechanical recycling. Started the first slide, I tried to concentrate the importance of this project on two bases, two vision, let me say. The productive process normally is planning the future. When I forecast to put on the market one product, I have to have an vision of the future, say what is the rules today, what will be the rules in the future, especially in terms of environmental impact and emission and so on, and additive that are used. So when I put today one product on the market, I have an idea of what is the next step, next target of the market. But at the same time, I have another problem. I have a problem to managing the past, especially in plastic product in general, but the plastic in this case, or PVC, that has durable. Durability of the product means that in PVC is, especially in the construction, you can have a product today in place that was produced 30, 40, 50 years ago. So in the other century, with different law, different rules, different laws. So I have to consider that I have to manage the post-consumer, the recycling of that. And the second aspect that this is linked to Europe, the other problem is I have to avoid that in the market will be present product that is not following the European law, because otherwise I have to manage also this in the future in the post-consumer management. Please, next slide, please. And at that, with this, and the web project had, as said before, the target to separate PVC from other plastic in the urban waste, and we starting with the project, Italian project supported by Viniplast, that the European Association of PVC producer and converter. We develop with a company that is named the Phoenix in Italy, one manual scanner that you can see on the picture, that you can find is PVC or not. You separate PVC from the other and send the PVC to recycling. Next slide, please. And the evolution of the PVC problem was not only to understand if it's PVC or not, or is polyolefin or other, but also to understand if is in the PVC is present legacy additive. Legacy additive are, in a normal term, normal word, is the substances that was used in the time that was built the product, or we produced the product, the article, and that after in Europe, the rich regulation are not more permitted. So we have to separate, the target is to separate PVC containing this legacy additive from PVC not containing. And next slide, please. And quindi, sorry, we with the company Phoenix, we develop one manual scanner or continuous process to select, to define or detect if there is this kind of the legacy additive. We put here three normal legacy additive that you find in our post-consumer product, that is lead, DHP, that is a plasticizer, orthophthalate, and MSCCP is a medium chain chloroparaffin. This one is three example that we had now a manual scanner to verify that is present, and if we have not the article where you can use the manual scanner, but we have the ground material, we can use the continuous process where we will separate the granule that are with, for example, lead from the other granule that are not including lead. Next slide, please.
2 more minutes, please.
Okay. Okay, this is two different. We have the plan, two different. This X-ray fluorescent, infrared fluorescent. These are two different detection system to detect different metal or other substances. Next, I. Okay, what is the importance of this mana scanner today, in particular the mana scanner, but also is that could be used also, is in our target to develop in the separation of the plastic and separation of PVC from legacy additive, including in demolition or refurbishment of the flat, of the houses in general. We have in mind one system like the next slide, please, that we can find how we can use our system, manual scanner or continuous process, to separate and define, separate the PVC that we send directly to recycling or to treatment before to recycling. In this case, we have we put the plastic item will be checked. With, if it's cable, we go to the copper recovery, and with the using after the continuous process separation of the containing or not containing lead, DHP or PVC, MSCCP. After, if PVC or not, and if it's rigid or not, you can have a different way to detect with lead, more lead than the cadmium or phthalate, and after you can decide to go directly to the recycling or to the system that to extract this legacy additive from the post-consumer waste, and with after the extraction of legacy additive, you can use as recycling. This is because it is important for PVC, because PVC is a material that can be recycled several times. Some people say also 10 times. And in this case is a resource that can, if we recycle, we reduce the emission and so on. Also, the problem is the cost and the optimization of the quality of the recycling material to implement this system in the best. This is the end of my presentation. Okay, the last
Thank
is
you.
Vini
Thank you.
Plus, etc., etc. Okay.
Thank you very much, Carlo. I don't see any immediate questions pending in the chat. If that is not the case, to keep the time, I would give the floor to Amardeep Wonder from Australia. Welcome, and we're looking forward to your presentation.
Hi, everyone, and thank you for the time today. Can you see my screen?
Yes, but it's not in presentation mode yet.
Yes, I'm just trying to present now. Is this okay?
Yes, great.
Great, thank you. And I will be very, very quick. Once again, thank you, everyone, for the time and opportunity today. I represent a small organization called Waste Recycling Environment Network. We are not only based in Australia, but also in the small island developing states of Samoa and Belize. And I'd like to talk about a project that we have been working towards in a small country in the South Pacific called Samoa. The population is about 200,000, and it has less than 7,000 babies below 2 years of age. And there's a reason for talking about babies. So the project is all about eliminating plastic containing diapers from the waste stream. Usually, hygiene waste or diaper waste is between 5 to 10% of any waste stream in normal countries. But in our small countries, with the large number of babies per capita proportionally for the population, the diapers form about 25 to 32% of the waste stream. So they are quite an important part of the waste stream, which and our small island countries also have almost never have landfills or appropriate means of disposal, which means these nappies end up in the environment and often in the oceans. So what we have done as part of this project is replace the nappies or the diapers with compostable alternatives. Every minute around the world, almost 380,000 diapers enter the landfill or pollute the earth. And compostable diapers eliminate this waste entirely. And we are actually composting these diapers to create nutrient-rich soil and replenish the earth. In terms of the design, it's very, very simple. We use a compostable pad along with a reusable material that goes around the diaper to keep it together. It's been patented, tested, and proven to be able to compost it to various national standards along with the International Standard of Compost. So one of the key parts of the project is that the entire process of collecting, sorting, and composting these diapers is co-created at the village level with the ladies of the village. The idea is to employ and upskill young mothers who would often not enter the workforce due to having a lot of small babies as well. Once the diapers have been provided and collected, we convert it into nutrient-rich compost using the May-Bruce method of composting, which does not require any large machinery or any materials. It's very, very simple. It's modular, and it can be made. It is currently being made using recycled materials within those communities. We are now using the compost that is being made using these nappies to grow food and doing some trials with the local university to ensure the safety of the compost made using diapers as well. So it's not just diapers, it's a systems change. The diapers are sold at price parity, so the same price as a family would buy normal diapers to each family. The mothers are engaged to deliver the new diapers and collect the dirty diapers twice a week. As part of this, the mothers also have important conversations with the young moms about maternal health, about child health, vaccination, and so on. The dirty diapers are then collected. We use a local inoculant using coconut milk and sugar, which is sprayed on top of the nappies. As you can see, the modular materials are used, actually salvaged from the landfill. And the diapers compost in between 6 to 8 weeks using the method. For every 100 babies, so currently we have 2 villages where this is going on. For every 100 babies, we're able to eliminate 700 kgs of plastic waste each week. We've been able to give 4 part-time jobs for local mums, and 5.5 tons of compost is created each year, but that's only for 100 babies. So who are we? We are a 3-person team. I am the one who's presenting today, but the project is being led by Kim and Jason Graham Nye, who are the founders of the Greater Good Diaper Project. And that's all from me. I would like to play a video, a 1-minute video, if I have time for it.
Absolutely.
Share? Great, thank you. Can you still see the video, or are you only seeing the...
Yes, but it's not playing yet.
Okay, yeah, I haven't started playing it. Thank you, everyone. That's it. I'm very happy to take any questions.
Perfect. Thank you very much for this interesting presentation. Henning already had a question. Henning, do you want to ask that yourself, or should I read it out?
No, can also ask. So thanks a lot for the presentation. I was wondering if you noticed that the consumers, because now the diapers are biodegradable, if there has been any kind of rebound effect so that they actually used more of the diapers, or on the other hand, if they were aware of the environmental consequences of this waste stream and thus have been actually even more careful how many to use, how to dispose them. Was that part of your research, or can you tell us a bit about these consumer change and preference changes?
So just to preface, the study was actually supported by the University UTS in Sydney, and they did a full consumer survey before, after, during the study. We have research available for that. I also saw a question around the materials. We have a full list of material available, which we can share as well for the nappies. As I said, I'm the composting expert. I don't know as much about the composition of the nappies and stuff, but I can tell you that I can compost them. The thing about the consumers was that, unfortunately, and it's an unfortunate thing, because they are more breathable nappies, and we are talking about the South Pacific, we didn't see this impact in some of the other countries we did this work. The women are actually ended up using less diapers because they're breathable, they're not causing rashes, they're not causing discomfort to babies, because this is hot, humid climate. And we feel like now we have to educate people about the fact that they have to change babies more often. Just because they're not feeling the discomfort, they must be changed. So there's a human health element to it. And for this project specifically, we are co-located with the Mother's Hospital. So we even collaborated with the nurses, the postnatal nurses, to ensure we can start educating mothers on making sure that nappy is changed every 4 hours, even if it has higher absorbency and it's making babies more comfortable. But a lot of this research is actually available. We are about to publish it.
Great. Thank you very much. Tahira also has a clarifying question.
Yeah, no, thanks for the presentation. Exciting project. The reason why I asked about materials, and I fully understand that your expertise might be on the end of life and composting side, is that in order for something to be circular and sustainable, you have to look at both upstream and downstream. And the other reason why I was asking, because we did a study on grocery bags in South Africa, and we compared, I mean, a whole use of single-use, normal fossil fuel-based, biodegradable, reusable, etc. And what we actually found was that if you looked at all the impact categories, not just plastic pollution, it's actually your general plastic bag with a certain amount of recycled content that actually comes out the best in terms of an average across impact categories, which is the reason why I asked regarding feedstock, where exactly you get your material from and how exactly manufactured.
Yeah, the key material is bamboo. But it has a layer that makes it sort of not what's the right word, where the water can go leak out, but can, because so, but also the design. So I guess the key for this product is a design. There's an outer shell which is cloth lined with plastic, which is reusable. So you're just replacing the pad inside the nappy. And of course, when you do a life cycle study, a reusable nappy comes out at top, right? So we know that a reusable nappy is best. But in our communities, most of our communities are coastal communities, remote, often with lack of electricity and wash facilities. So not being able to wash properly is a big issue for our communities, which led us to use the compostable inner insert. On the other hand, the same outer shell can be used with the reusable washable insert as well. So the thing is, you can have an outer layer with the cloth material, but the insert can either be a compostable pad or a reusable pad, depending on the community that you're trying to target. For us, we found that washing facilities are not easily available for a lot of our remote communities, and often the disposal practice is to throw the hygiene item actually in the water, because traditionally and culturally water is seen to be clean.
Great. No, thanks. And seems to be a lot of thought into the design and the manufacturing as well. Appreciate the additional detail.
Anyways,
Thank you very much. I have a last question. Sorry.
of course.
There have been similar studies in Europe on composting hygiene products, and why it was not forbidden under the current regulation was the contamination with pharmaceutical residue, so to speak. Now, you said that heating up to 68 degrees, when I got that correct, would remove any contaminants to be below any threshold that you have regulatory. Is that by any global standards, or is just the contamination with hormones and pharmaceutical byproducts lower in these communities?
I think we have been testing our compost to the Australian standard, the AS4454. I'm able to share the results of the testing with you, and we have yet to find any of the contaminants, the traditional contaminants that we usually see. I have to mention here that we are not just composting diapers. We layer it with organic matter, which is grass and green material, which is very fresh, and we actually need it to be green for our inoculant to work because you're preparing it locally as well. So there might be a bit of a dilution effect going on as well. So we are not. It is not just a compost made from diapers only. It has a number of other organic waste that is being mixed in it with it as well.
Great. Thank you very much. So then we, I think, move forward to Henning's presentation. I'm looking forward.
Thanks a lot, Katharina. Thanks a lot for having me and the possibility to present some outcomes of a project that we recently finalized that was looking at reuse as one of the options to reduce plastic waste. And here we had the opportunity to investigate and analyze pilot projects on 3 different continents. And I'm happy to share some of the insights that we draw from that process. On the next slide, you see that this was part of an quite large-scale GIZ project funded by the German government, the so-called Circular Cities Lab, that set up reuse pilots in different cities in Albania, Colombia, Georgia, and South Africa. And you already see that these countries, of course, have very different framework conditions. They are on very different levels when it comes to circularity, but also the treatment of packaging waste. And against that background, we as Hafen City University have been asked to set up a monitoring and evaluation framework that looked not only at the specific product, so the reusable cup, for example, but took into account the full ecosystem of setting up reuse systems on an urban level. So we looked into environmental aspects, tried to measure potential greenhouse gas emissions based on orienting life cycle analysis, but we also took into account social impacts, especially with regard to contributions to empowerment of women and also the economic impacts. Looking at the evaluation of startups, for us, it was really important not only to look at how did they begin, but to also look at what did they actually achieve in terms of changing consumer behavior, especially with regard to the uptake of circular and reusable alternatives. And against that background, because these startups just began to implement, and we also looked at the factors that were hindering the implementation and the rollout of these different initiatives. And what we did was to combine different research methods. We had a couple of structured questionnaire where we asked about quantitative data, especially with regards to the life cycle assessment, but we also conducted semi-structured interviews and asked about the perception of the success and the framework conditions of the different startup activities. On the next slide, you see that with regards to the factors that are hindering reuse. No, there has been some concern in the beginning also by GIZ, and then we also see that in the literature that reuse, the obligation for customers to switch from a linear, quite simple system to reuse models that would also obligate them to bring these reusable products back. That could lead to the loss of customers. And for us, it was quite interesting to see that all partners involved in this project strongly disagreed with this hypothesis, and that also in all four of the countries where these pilots have been conducted. So it was definitely not the fear of economic disadvantages that led to a sometimes quite slow uptake of these pilot activities and the reusable products that they offered. It seems that way more important was the integration into the existing infrastructure, and you can see that on the next slide, where we tried to summarize and synthesize the factors hindering action, so the barriers. And here we have across all the different activities, uncertainties regarding the cost of especially sanitation equipment. How can we make sure that reuse doesn't cause any problems, disadvantages, but also fears of the customers with regard to the hygiene of the already used product. We also had uncertainties about the ease of integrating reusable products into the existing waste collection system. So what to do with them at the end of the use phase. We had uncertainties about the ease of launching the project, especially with regard to coordination with municipal administrations. And then we also had uncertainties surrounding the effectiveness, the ease of implementation, and the usability of a tracking system. And so how can the startups better understand where their cups or bowls actually remain? How do they get access to them? How can they recollect them for a second use phase? With regards to the environmental impacts, and that's on the next slide, we tried to assess the environmental potential benefits based on just in the beginning a baseline scenario of the current linear system, and then looking at the reusable alternative. Here for us, it was interesting to see that startups, of course, have a quite limited influence on the background system. For example, now how has the plastic cup produced? What share of recycled materials did it include? What was the transportation mode? All of that is beyond the influence of the startup, but nevertheless, of course, really important. We've seen that around 40% of the greenhouse gas emissions linked to the reuse system were out of control of the startups that we worked with. Nevertheless, and that's on the next slide, we've seen that 4 out of the 8 pilots that we evaluated showed immediate greenhouse gas savings after an initial phase of 3 months. This seems surprising because in the literature, we often see very significant reductions from switching to reuse systems. But within this first 3 months, we still had long transportation distances. We had the procurement of additional machinery. So that might explain why only 4 out of 8. We've also seen that all pilots have the potential for a net positive environmental benefit if they continued to get better, more efficient, and more structured, as we've seen during the first 3 months, where we'd also try to evaluate the learning curve. The key points that the pilots have to improve on are especially the return rates. Often the deposit was too low. The economic incentive to actually return the reusable cup was not sufficient. And we also had the challenge of transport distances. In countries like Georgia, we don't have a filling and refilling and washing infrastructure. So it was necessary to transport the empty and used cups, for example, over quite long distances, and that mainly was diesel trucks.
2 more minutes, please.
Already my last slide. What are the key learnings? We've seen that when we tried to compare different reuse pilots, that especially with regard to the environmental benefits, the specific implementation of the concrete business model has been much more important than the spatial context. They all had very similar challenges, very similar barriers to address and overcome, regardless on which continent or which specific city the pilot took place. Now, of course, we had different regulatory frameworks, but the basic questions and the crucial points to address for them have been quite similar. We have also seen that switching from a linear to a reuse system clearly increased the level of complexity. They had to deal with much more partners. The number of transactions, and that's what we try to monitor, has increased. And I think that is one of the key barriers to be addressed. How can we make reuse easier also for economic actors that try to implement reuse systems? And then finally, we've seen that the startups had to put a lot of effort into the development of standards, for example, with regard to the size of the packaging, to hygiene standards. And that was one of the key learnings for us. We need globally harmonized standard, not only for the linear system. There we have them for decades, and they work really well and make the system so efficient. We also need that on a similar level for reuse systems. With that, thanks a lot. Really looking forward to your thoughts and feedback.
Thank you very much, Henning. Tahira was asking if you can share the link to the study. I would have a clarifying question. The environmental impact assessment that you did, was that on a level of reuse system that is scaled up, or was that on the startup level trying to get their foot into the market?
Yeah, thanks a lot. That's exactly the important point. We only had data for this initial phase. The startups began, it was quite challenging administrative process to set that up in the different cities. They began 6 months ago. So we only have data from the first 3 months of implementing the pilots. And now we have to come up with a reasonable assessment. Now, how could they improve over the next 6 months or year? And would they reach a break-even point with regard, for example, to greenhouse gas savings? So far, 4 out of the 8 increased the level of greenhouse gas emissions.
Sorry, a follow-up question. And that was, if I get you correctly, mostly due to the additional transport and the washing, or because you had to throw so many additional reusable, but in the end, single-use cups or whatever it was on the market?
Yeah, that 2 points. The first thing, loss rate. We had return rates sometimes below 10% because the deposit was way too low and people just kept the cups, for example. One of the pilots was a festival reuse system for the pet, and the people took the cups with them when they went home, and then you don't have any saving, you have additional effort. And the second point, as you mentioned, transport distances without a washing infrastructure, they sometimes had to fly the cups out to other countries, wash them there and bring them back. And then it's not surprising that that doesn't really make sense from environmental point of view. But of course, they have clear ideas now how to improve that.
One question from the audience on the same aspect. So what were the particular cases and activities where this reusable packaging was used for? So cups was one, but maybe there were other applications?
Yeah. So the pilots, for example, worked with hotels and offered reusable cups. We had one pilot working with the music festival where a reuse system was tested. We had one company working in the cosmetics sector, offering cosmetics in reusable containers. So they have been quite different, and also that made it not so easy for us to draw generalized conclusions, nor even to come up with a comparison the different pilots. And of course, happy to share the link to the final report. We are still working on it. We have a month, but then I can share that in this group.
Great. Thank you very much. Are there any other questions from the audience to any of the speakers? I don't see any in the chat. Are there any questions from the speakers to the other speakers? Okay, if not, then there is a question from the session chair to the speaker. So thank you very much. I found it particularly interesting that we had in these 4 presentations, like almost all levers of the circular economy. So we had recycling, composting, reuse, and recycling again. And I was wondering now if the 4 of you would have to vote. We have this waste hierarchy, but each of you presented obviously a different lever of this. How hopeful are you that your lever will prevail, and how do you see your solution relative to the other solution? Maybe you could give a quick answer on this. So, for example, Tahira, if you want to start, so you illustrated very nicely how the recycling sector could contribute to welfare, to jobs, and so forth and so on. But do you also see a role for Henning's suggestion on reuse or even for composting? Is that also part of your solution?
Thanks. And I think, yeah, interesting question. So first of all, I probably want to preface that by saying that there is no silver bullet. I don't think that any particular intervention, and if we're talking about circularity intervention, is actually going to sort of be able to achieve all the targets. So whether it's reuse, whether it's recycling, anything within the 3R, 9R, I don't know how many R's there are at the moment. And then I think it's also important that while perhaps the focus is more on material pollution, that we don't also forget of the other environmental impacts. And that's why our study looked at not just circularity, but also decarbonization strategies. The reason why the recycling was focused on was because we need to be context specific, and in South Africa in particular, as I believe the case with many developing countries, mechanical recycling is the sort of dominant circularity technology that is available. So I am confident there's quite a lot that's being done, and recently I just had to judge the recycling awards in South Africa that happens every year, and you can see in terms of the recycling that's happening and in terms of innovation, but more from the design aspect. So that's more upstream. I think that they all sort of, maybe just to conclude, that all the parts need to work together, both upstream, both downstream, both circularity and both decarbonization, in order to achieve maximum benefits across all your environmental impacts.
Thank you very much. That would have already been a very nice closing statement, but nevertheless.
Sorry for stealing it.
No, that's great. I would be very much looking forward also to the other participants' perception. Maybe, Carlo, I mean, you presented a solution that could actually scale up recycling for PVC, but I guess the biggest threat to PVC is actually not the recycling, but the potential phase out or regulatory threats for PVC as such. So how do you see other levers for PVC as reuse or prolong life? Certainly not composting, I guess.
No. But speaking about PVC has some advantages, some disadvantages. The disadvantage is that need some, like in general, also the plastic, but especially PVC, are need to be added to substances so that we have to control and improve in terms of the kind of substances we use. Considering also that this is, we speak about Europe, but if we speak about at the world level, there are different regulations, so there is differences the feeling of the PVC in different countries, where and in my opinion, probably for certain kind of issue, one world agreement that needed to be done, in general, not only in PVC, but also in plastic in general, considering what happened in the last in Geneva, the same city, that there was different position. So I think that in certain way, compromise in the next years maybe has to be. Regarding PVC has the advantage that it could be recycled. So if we are able to separate and select in the right way and to have the possibility to have a clean product waste or recycled waste, PVC has the advantage that it could be recycled several times, I said before. But the problem, the main problem, and the target of the project that I present is to how to collect, how to separate, and how to recycle, and what we have to improve. The manual scanner or the continuous process is important tool to because when you demolish a build or in general the citizen use the plastic, they don't know if it's PVC, if it's polyurethane, and so on. For them, it's plastics put in the same bag, bead, and nothing else. And the problem is to separate, because of course mixed plastic means wrong solution, but we need to have to separate, eliminate what is the legacy I did before. This is a way that we are working, so several years, but it's not finished. And the message that I send is that the PVC has the technology to resolve the problem of recycling. The problem is that we have to collaborate with all the system, not only the value chain, but also the authority and so on, to find the best way. In general, what is the recycling in the world, my feeling is that the first problem is the cost. I think
Yes.
the cost is because we are able to calculate CO2 emission less and so on, what means and so on. After to the citizen, to the public, is the cost of for who produce, who recycling, who use. This is, in my opinion, one question that's at the authority level is to be resolved in general.
In that regard, I think you were sitting in the same or rowing in the same boat as Henning is, because probably also insufficient or sufficient scale up of a more or less separate stream, although for different usages then, is the challenge that you are facing. And for that, I think both of you are heavily dependent on the consumer and consumer education and willingness to to participate and bear the cost of separate collection. Maybe Amadip has already a solution for you around the corner, because maybe Amadip, you can say a few last words actually about how you managed to do this community engagement, which I found the most fascinating part of your project. Because I mean, if you have like one contamination by a conventional diaper, I think that is a huge threat to your entire composting stream, because the traditional super absorbent probably will never compost. So how did you manage to get this kind of deep consumer or mothers engagement in this case?
I thank you for the opportunity. I know we only have 1 minute left. But I just wanted to start by saying that I feel like my solution is actually one of the many, many R's that Tahira talks about, and it's more about redesigning. So I feel like the key focus of our project was actually originally working with mothers to determine what were the biggest challenges in them moving to a more compostable nappy. But to be completely honest, I think Carlo's right. For us, it was also cost. We had to find a way to make our nappies at cost parity. No one was going to buy our diaper if it was going to cost more. Doesn't matter how environmentally positive they are, doesn't matter how much change they want. at the end of the day, it impacted the hip pocket. So we actually had to find ways to um, to make our diaper available at cost parity, and that was the only way for us to get into working with the mothers. But in order to prevent contamination, that's where we came up with the idea of joining forces with the local hospital, because they knew who were the young mothers, they were the ones who knew what the challenges they were facing, and then we engaged them, the mothers themselves, to go and be the collectors. Because they're the ones who know how many, just the sheer amount of work that goes into raising a small baby and the challenges that those moms might be facing. Again, and also the promise of a job was really, really helpful. And we found that we had very, very small challenges that these mothers had to having jobs, like being able to drive. They didn't have driving licenses, being able to talk to someone about how would they go about getting a job. And we found ourselves doing very, very small things like driving lessons for young moms and some sort of simple English lessons and stuff like that to pick the barriers that were preventing them from being engaged, and then work on those to get the engagement. It took us more than a year to get the project going. And we're very happy that it is going now and hoping to expand across the Pacific.
Great. Thank you very much, and apologies to Henning because we are running out of time, but it doesn't mean I didn't want to hear your answer. I thank all of you and also the audience for being here. It was very interesting. Thank you very much and have a nice day.